negative quadrant. And then this one's going to have the x is positive, and the y is negative. Positive y, and these will both be positive.
Okay, so very good. Very good. So we have the graphical display of data is very common. You've all seen it. They'll plot out, say, stock prices for the last year. And you'll see basically quadrant 1, because you don't need all 4 quadrants, because the years go positive and the numbers are all positive. The stock market doesn't go below 0. So all the numbers are positive and the years are always positive. So what you see there is just something that allows you to visually show the trend of data. Okay. Now, these are called Cartesian coordinates. That's useless. Throw that away. And we call them that in honor of René Descartes, a French cleric and mathematician that invented this way of displaying data. That's all. So we name things after, like Euler's number, you know. We name things after people who discovered them or developed them. Now the thing about the quadrants is that it's all well and good to have 2 lines, but the lines are number lines. Just like the number line we talked about in the first class. So over here, we have 1, 2, 3, 4, 5, 6, etc. And here we have -1, -2, -3, -4. -4, -5, -6, etc. And over here on the y-axis, 1, 2, 3, etc. And -1, -2, -3. And if you take a piece of graph paper, which by some accident of fate, I actually have some of. Had some of. Have some of. So I'm going to suggest, I've got all right. A bunch of these. Okay, each of you take 4 or 5 pages of these. I had some. And 4 or 5 pages. Yeah, take about 3 of these. So that's about all I have for now. I can make some more copies on the break. So you'll note that the way this is set up, I'm going to stand up here. So this is partially visible, I hope, in the camera. you see that we have the y-axis and the x-axis. That means that we can use these things for presenting data. We can also use them for solving equations. Okay? Now, if we look at this piece of paper, at these graphs, I'm going to erase this wonderful diagram that Jessica put up.
That is pretty
Let's do something. I hope it works. Make it a little smaller. And this center point, where the two axes intersect, is called the origin. It's the point from which you start, the origin. And it is, by definition, the 0 point. Okay? So, on this paper, which is marked off this way, any point here can be described by the value of x that it is away from the origin and the value of y that it's away from the origin. So if we go over here, and I'll ask that you be careful of my artwork, but if we put a point here, it's approximately above the 5 on the x-line, and approximately at the 6, positive 6, on the y. So what we say is this can be represented by saying that this is the point 6. Okay? So if we, by convention, we give the, excuse me, we give the x value first and the y value second. That's our convention. So that if someone says to you, I want you to mark out the point 3, 2, you're going to go 3 to the right on the x-axis and 2 up on the y. And that's going to be the point. So, which would be approximately here. Okay? So every point has an address, basically, which is the x and y value. So anything that is actually on the y-axis, a point that's on the y-axis, is right above the origin, so the x value is 0. And so this point right here, I'll pick a different color, is 0, 4. And they're separated by a comma. Okay? So 0, 4 is that point. If it's on the x-axis, such as right here, it's -4, 0, because the y value, it's at the origin. So there's nothing above that. So the y value is 0. Note the x value is -4. If I gave you any two numbers, you could plot it out on your piece of paper. Okay, that makes sense? All right. So that's how these coordinates work. We use them for solving problems. And the problems that we can solve, or we use them for presenting data. I mentioned stock market data. If we're looking at Say the closing value of the stock market on December 31st, or the last, if that happens to be a Sunday, the last working day of, the last day of the year that the market is actually open. We can present that data. So let's just say that, you know, I haven't put any numbers on this or any values on this. So we're just going to pick a few numbers, okay? So at the end of year, whatever year we're starting, then it has this value. The next year, it might have slightly more. The year after that, it might be up. The year after that, it might be down. The year after that, it might be up further. Okay. So we present data lots of different ways. We can connect it by a line. Okay. The line looks kind of jumpy, because it is. But on average, that line has been going up. And that's what stock market analysts use to tell people not to panic when the stock market takes a gigantic drop, like it did basically all through the month of February or so, because it will come back. Over time, the stock market goes up. This is fundamental information that people use for making various kinds of investments. Okay? It's what if you happen to have at work, if you happen to have something like a 401k, some sort of investment account that you participate in, which I suggest you start doing as early as possible in your working career. They will encourage you to invest in the stock market, because over time, the stock market goes up. There's never been a 10-year period where the stock market went down. There have been 5-year periods where it went down, but never 10. So if you're looking at your age now and thinking about, you know, when you're going to retire, say at the age of 68 or so, you got a lot of years for this money to grow. And there's various different strategies. There's various different kinds of investments. They present all this data to you. And you make a decision as to how tolerant you are of risks, because the riskier the investment, the higher the return, or the steeper the loss at times. But over time, again, they go up. So if you're a young person, you would be putting money away that you can't really legally touch. Well, you can't, you want to pay a fine, that you can't touch until you retire in some sort of retirement account. You may want to take an aggressive investment strategy and then just ride the train over the years, because in the long run, you'll do very well. Those are the kinds of data that we see. We see it in looking at population trends in this country. And so we can actually see over the years the rise in that population. And we do this by two methods. One is the census that we take every 10 years. Those are hard data. And the census is when you count every single person, okay, that you can get to. And I've participated in doing the census, and sometimes it's a challenge. But we get 99.999% of the population when we do this. So we have a good idea on a 10-year basis. We have absolute numbers on a 10-year basis. And then we have estimates that we follow, looking at births, deaths, immigration, and so forth. We look at this to project up until we get to this next census, which will be in 2020, when we'll get an absolute number again. So we use this for a lot of purposes. Data to collect data is, there are people who just love data, so they just collect data. And to me, that's kind of, why are you doing it?
Right.
You know, if you're doing it for a purpose, great. If you're just collecting data, you know,
You never know the purposes of the data. May serve a purpose in the future that was unforeseen present.
yeah, but people who just collect data to collect data, they don't care. And in reality, most of what they collect will have no use whatsoever. Yeah, it really isn't particularly interesting to me how many cats live in Manhattan. Now,
Unless.
animal control may want to know that answer.
Never know, like a disease could break out.
And in fact, we may have a problem with the rising population of rats in Manhattan because they're carrying nasty, diseases, bacteria, fungi, parasites. That don't affect them, but do affect humans. So it's really kind of interesting. I'm just reading that statistic. I look at a lot of things, and so I have a lot of facts stuck in my head that are seemingly useless. So I understand wanting to know. Anyway, so we use graphs for that purpose. Now, so the question becomes, how do we use it for solving equations? And that's really going to be the focus of what we're going to do for the rest of tonight. You will have a take-home homework assignment tonight. It'll be the only homework this week.
No discussion?
There's no discussion this week. There's a take-home homework assignment and then a final. Hey, John.
What's up, Mike? Sorry, I'm.
How many questions on the assignment?
There are 30 on the assignment.
Will you giving this today?
I will give it to you. I have it printed out already.
All right, sweet.
So
We have class time to, we have class time to work on it?
I hope we do. We're going to talk about solving equations first. This is going to be about linear equations and graphical solutions. Your final will also have some of that. The final, I haven't finished writing it yet. You looking for the stapler, John?
Yes, sir.
I think Nate may have taken it next door.
There's two.
There's two.
Oh my goodness. Oh my
That's hilarious.
goodness.
Mike was just trying to
I
get
guess.
the
It's okay, I'll give it back. I'm not going to take it.
That's right. We believe that vengeance is a dish best eaten cold.
Cold.
I don't want
Oh, that's funny.
But we can use these things for solving these equations. So we're going to go through that. But first, I want to describe a linear equation and talk about the concept of the intercept and the slope. Slope, you all know about slope. It's how far up something goes or down something goes for a unit of distance across. It's the same thing on a graph. Now, the structure of a linear equation is y equals mx plus b, where m is the slope, and B is the y-intercept. Meaning where it crosses the y-axis. Okay. This defines a straight line. And by straight, I mean straight, bless you. Okay. So if we take how about that? So for the equation, y equals 2x plus 1, 2 is the slope. And what that means is that it rises 2 units for every 1 unit change of x. Okay. And 1 is b, the y-intercept. Okay, so y equals 2x plus 1. How do we plot this? Well, easiest way is to make a little table, x and y, and choose values. If x is 1, then y is 3. 2 times 1 plus 1 is 3. If x is minus 1, we want to have negative and positive. The reason we do is we want to be sure that, or if x is minus 1, we want to be sure that we actually take this line across the y-axis when we're doing it this way. So minus 1, minus 2 plus 1 is minus 1. If x is 0, then y is 1. 2 times 0 is 0 plus 1. If x is 2, then we have y is 5. So now, if we plot this, we've got a point at x equal 1, y equal 3. That's going to be right here. At minus 1 and minus 1, which is going to be right here. At 0 and 1, which is going to be right here, right? And at 2 and 5, which is going to be right here. And if you'll pardon my placement, we can draw a line down there, and it is a straight line. Okay. Now note, because what we did, one of the things that we did last week was we used pairs of equations to solve for x and y. Graphing one of those will not solve for x and y. And we'll come back to that. So what we want to do is look at how we can, at what the structure of our linear equation is. M and B do not have to be integers. Okay? They can be fractions. All right? Plotting them becomes then a matter of eyeballing, but that's all right. But we can solve these things. So let's take a look at a different equation. And I'm going to start with just 2 points. Because of course 2 points make a straight line. If you connect a line through them, it's a straight line. And you can extend that line as far in either direction as you want, as long as you keep it straight. But 2 points will define a straight line. Right. So let's pick 2 points off this thing. Three and 2. It's not even any better, is it? Three and 2, minus 3 and 0. Okay. Now we can put a straight line through here. Okay.
Do that again. Which 2 numbers did you use?
I used 3 and 2 and minus 3 and 0. Okay. So I can draw a line between those 2 points. And we can calculate the value of M and of B. Okay? So what is the definition of slope? We define slope in 2 ways. One is rise over run, how far up it goes or down, versus rise divided by how far across. So how far up or down it goes on the x-axis, how far across it goes on the y-axis, or on the x-axis. How far up and down it goes on the y, how far across on the x. Sorry about that. Okay? So how do we define this? Well, first off, the other definition is y2, useless, y2 minus y1 over x2 minus x1, where the 2 and the 1 refer to a specific point, so that we've chosen, the first point and the second point. How do we know what the first point and the second point is? Well, the first point, y1, is the one to the furthest left. y2 is the point to the furthest right. All right? So this is x2, y2, and this point here would be x1, y1. Okay. Why do I know that? Because a positive slope is one that goes up from left to right. If you're looking at a graph and you want to calculate which is y2 and which is point number 2 and which is point number 1, think of it as the slope going up is positive, slope going down is negative. So number 2 has to be the furthest to the right, and number 1 has to be the furthest to the left. Okay? So in this case, we've got y2, which is 2, minus y1, which is 0, divided by x2, which is 3, minus a minus 3. Note that I put that in parentheses because we need to keep track of signs. Okay? So that's 2 over 6, which is 1/3, and that is the slope. So the slope is 1/3. So now we have our equation.
Okay, cool.
y equals
Just a
1/3
video later.
x plus b. So how do we calculate b? Well, we could say, well, it looks like it's 1, but we can't trust that. So we calculate it. We know a value of x and a value of y for 2 points. So we can take those values and substitute them into this equation and then solve for b as the unknown. So we've got y is 2 equals 1/3 times 3 plus b. Right? Does that make sense? All right. 1/3 times 3 is what?
What was
One.
1/3 times 3 is what?
One.
1, right?
Okay, but did you just take the x value as 3?
Yeah, I took this point over here.
Okay.
So
Does
x
it
is 3 and
specifically
y
have
is
to be
2.
x2? Does it specifically have to be x2 or can it be x,
It
the
could be either
negative 3?
one. You'll get the same answer.
Okay.
Okay, it'll be the same answer. Okay. So I've taken this. 2 equals 1 plus b. 2, and we subtract 1 from either side. So we have 1 equals b. So b is 1. So our equation now is y equals 1/3 x plus 1. So we've just recreated the equation by knowing 2 points. Okay. We're 8 minutes late on our break. Take 15. And we'll come back and, does that make sense, Bernard? You up on that?
Yeah. It's just gonna take a matter of me just doing it more and more and more and more.
Yeah, we'll do some. We'll have some more, and the homework is going to be a mix of in class and finish at home. So we'll do that too.
Yeah, I've noticed, like you do a good job in instructing and explaining things. It's a matter of me to keep out doing it and doing it and doing it. Then it starts to click for me.
Practice is what makes perfect with math.
Right.
Yeah.
Yeah. So it's just one of those things I'm getting adjusted to.
Right.
What's up, Carol? See you winning again. Scramble. Yeah. The hot. Settle down. Settle down. Maybe something.
You doing all right, Daniel?
Yeah.
Will you hand out the assignment in the class?
I'll hand it out, I think, as soon as I get through with the majority of what I'm trying to talk about, so we can start on it and maybe get through a couple of questions first, so people will understand it a little better. How's that sound?
And Mr. Berkey.
Ah,
Yes.
all righty.
I did it on the,
Super.
and then I printed it.
Sounds good. Wish I didn't have such a case of sneezels tonight. Let's see. Let's see. Okay, we may as well. Here comes Bernard. I presume Trevor will be back soon. We'll go ahead and get started on a couple of things. So, you can always, if you're given 2 points, since we know 2 points are all you need to make a straight line, you can calculate the equation of that line from those 2 points. Solve for the slope, and then use one of those points to calculate b. Right?
Right.
Okay. We can also, given 1 point and a slope, we can calculate the equation as well, right?
So there was one question like that in the study guide. Calculate the equation, find equation containing 2 and 3 and m equals.
All right, let's use that one out of the study guide then, since y'all can download that. So let's,
Oh, it's -4.
pardon?
It's -4 actually.
Slope is -4. Okay, so that just means it goes down from left to right. Okay. Okay. So okay. And then we have our coordinates. And I'm not going to put the numbers. Okay. Not going to put the numbers on that. Because they take up too much room. So the study guide question was, find the equation of the line if m equals -4, and we have the point what?
2 and 3.
2, 3. Okay. So 2, 3 is that point right there. Okay. And we know the slope is -4. So the slope going from left to right will be going down. Right? So if we go back to our mx plus b, we're going to have y equals -4x plus b. So we have 2 and 3 are x and y. So 3 equals -4 times 2 b. Or 3 equals -8 plus b. And now we add 8 to both sides. And we get 11 equals b. Okay? So the y-intercept then, since I only went up 10, is there. So this is going to be our y-intercept. So our straight line goes down like that. That's pretty steep, but remember that the slope is the number of point changes of y for every 1 point change of x. So the slope being -4 means that the point that as we move to the right on the x-axis, the change in y will be -4 for for that 1. So that's a very steep slope, not one you'd want to ski. Right?
Right, so so B equals 11 is the final answer. That's the equation. Find the equation.
No, that's clear. So our final answer now is y equals minus 4x plus 11. Does that make sense? So when they ask for the equation, they want you to go back to y equals mx plus b. They want you to find m and b. And we can do this, as we know, by knowing 2 points or a slope and a point.
Got it?
Okay? Right.
Because now we can use this equation to find any point on any x and any y.
Mhm.
Got it.
So you can calculate if x is 3, so y is going to be minus 4 times 3 plus 11, or minus 12 plus 11, so y is minus 1. So you can do that anytime you want. We know that answer. And remember, we can plot this out knowing with the 2 variables, we can draw our line. Right? Does that make sense? Okay, so that's one way of doing it. Now let's take a look at a couple of special cases.
Uh-oh. No.
Okay. If the line is parallel to the x-axis, what do you think the slope is?
0.
0, right? Because there's no change in y. Remember that slope equals y2 minus y1 over x2 minus x1. So that if the line is parallel to the x-axis, the y value is the same for every x value. Therefore, y2 minus y1 is 0. So the slope is 0. Special case number 2. The line is parallel to the y-axis. What's the slope? Somewhat of a trick question. You can't calculate it. Because in this case, x2 minus x1, the x value is the same for every y value. So x2 minus x1 is 0, and you cannot divide by 0. So the slope cannot be calculated. It's what we call an undefined term. So that's kind of a trick question. So let's play a little slightly different tune here. And look at how we solve linear equations. All right. Now remember, we have the pairs of linear equations that can be solved, in which we use either substitution or elimination by addition, right? We went through those 2 different methods for solving pairs of linear equations. All right. So let's take a look at how we can use a graph to solve linear equations. Okay. Let me just make sure I wrote those down correctly. So we have two equations. X minus 2y equals 4 and x plus 2y equals 8. Okay. So these two equations can be solved by graphical analysis. We don't care about the slope, and we don't particularly care about the intercept. We just care about what are the points on those lines. So what we want to do is make a little table for both of these. Okay. And we just choose a value of x. I always like to start at 0 because it's easy, right? So if it's 0, then what we have is 0 minus 2y equals 4, or minus 2y equals 4, right? Divide by minus 2 and you get y equals minus 2, correct? Everybody happy with that?
Yeah.
Okay. Okay, x equals 1. 1 minus 2y equals 4. Okay. So we subtract 1 from both sides and we get minus 2y equals 3. So then we divide by minus 2 and we get y equals 3 over minus 2, or minus 1.5. Does that make sense? Minus 1.5. 4. If x is 4, then we got 4 minus 2y equal 4. We subtract 4 from both sides. Minus 2y is 0, so y has to be 0. Okay. And let's just choose 8. I'm thinking easy numbers so that we don't have really bad things to see here, bad calculations. So 8 minus 2y equals 4. Subtract 8 from both sides, you get minus 2y equals minus 4. Divide by minus 2 and you get, pardon? You're dividing minus 4 by minus 2. 2. You get 2, right? All right. So now we can draw this line. At x equals 0, y is minus 2. At x equal 1, y is minus 1.5, which is about there. At x equal 4, y is 0. And at x equals 8, y is 2. So we can roughly sketch our line through like that. Okay? Make sense? Everyone? Okay. Let's go to the other equation. If x is 0, then 2y equals 8, and y equals what?
Okay. I was still on this. I was still connecting my dots.
Okay.
Zeros, then just divide by 2, 8 divided by 2. 4.
So if we've got 0 is x, then we have 2y equals 8, right? So we're going to divide by 2 on both sides to get y equals 4. Okay? If x is 2, right? What's y?
2, 3.
3. You can subtract 2 from both sides, right? So you're going to get 2y equals 6, y equals 3, right? If x is minus 2, what's y?
It's gonna be
5.
6.
Okay. We're gonna add 2 to both sides, right? So that's gonna be 2y equals 10. Right, so y equals 5. Okay. So now we have 3 dots. Let's plot those. At x equals 0, y is 4. At x equals 2, y is 3. And at x equals minus 2, y is 5. So now our line draws right down through there. Okay. And that intersection point is the solution to the problem. Okay. That's not right. What's wrong? What did I do wrong? So, obviously I didn't draw my line very well. Or lines. Let's go back and take a look at this. If x is 0, y is minus 2. If x is 1, y is minus 1.5. Okay. So obviously I didn't draw this out well, so we need to do this on graph paper. Because everything here is correct. If we go up here, and we do one more line. If x is 6, then 2y equals 8, or 2y equals 2. We subtract 6 from both sides, and y is 1. So we've got a point out here. I just didn't draw this well, that's the problem. And the line goes through. So what you want to do, what I'd like you to do is draw this out on the graph paper I gave you. Draw out that little table. That's going to be more likely to give us an accurate result. And so that's what you got?
Yeah.
6 and 1?
No, I didn't get that far.
Okay. So let's,
It's gonna be off.
Just use any of the graph tables?
yeah, any of them. I'm going to use the larger one. problem with trying to do these on the board. It's much easier to do them on paper.
She's gonna be caught in zero. I don't know. Four and one.
Okay. So
Yeah, 6 and 9 is a good,
yeah,
just like the point.
and you can check that by plugging the answers in. But the intersection point, if you graph this out using those numbers, is 6 and 1. And you can check by, we know that 6 and 1 is a solution for x plus 2y. So the answer is, does it also work for x minus 2y equal 4? So we've got x equals 6 minus 2 times 1 is 2, right? So, right? If x is 6, we've got 6 minus 2y equals 4. Subtract 6 from both sides. Minus 2y equals minus 2. Y equals 1. So this one, we could hit the solution by having a common pair of points. But the intersection of the graph, this works well when the actual answers to these linear equations are not integers. Okay? This kind of graphical analysis does this job very, very well. But you have to use graph paper to get it accurately, and preferably a straight edge of some sort. I use the edge of my textbook, for instance. But we've got paper and other things that can be used for that as well. But that's how we solve these kinds of equations. Okay. So also, I want you to understand that we can solve these equations for any of the variables, m, b, x, or y, by following standard rules of algebra, which are whatever you do to one side, you do to the other. Okay? So if we want to solve y equals mx plus b for x, the first thing we do is subtract b from both sides. We get y minus b equals mx. And then we divide both sides by m. So we get x equals y minus b, all divided by m. So we can solve any of these things very quickly, okay, by rearrangement. So, questions? Okay. Now, just because Daniel was a smart aleck, I'm going to show you how you can solve a quadratic equation using a graph. Okay? And we're just going to take a very simple quadratic equation. Okay? Y minus 7, or x squared minus 7x plus 10. Okay. 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 We're going to do this by, instead of setting the equation equal to 0, we're going to set it equal to y. We're going to use various values of x to calculate values of y. Okay? So again, we're going to do an x and a y as a table. And again, I'm going to start with 0. In this case, it's pretty easy. Y equals 10, right? If x is 1, x squared minus 7x, we got 1 minus 7 is minus 6, plus 10 is y. So minus 6 plus 10 is what?
4.
4. Okay. So that's a 4 and a 10. Let's do a 2. X squared is 4 minus 7x minus 14. Right? Plus, so 4 minus 14 is minus 10 plus 10. Y is 0. In a great place. All right. Minus, if x is minus 1, I'm not sure we want to go there. Because what we're going to get is minus 1 plus 7 plus 10. So y is going to be 16. That's way off my graph. I'll put it down. Okay. But that's okay. Okay. X is 3. That's going to be 9 minus 21, which is minus 12, plus 10 is minus 2, y is minus 2. Okay, so let's start plotting those and see where we're getting. If x is 0, y is 10. If x is 1, y is 4. If x is 2, y is 0. If x is minus 1, it's 16. That's way up there. If x is 3, it's minus 2. Okay. If x is 4, let's go over here. We've got 16 minus 28. If x is 4, Got 16 minus 28, which is minus 12, plus 10 is minus 2. Okay.
That means the y is -2 on both 4 and 3.
Wait until I get done. We'll see what this looks like when we get done. If x is 5, we've got 25 minus 35, which is 10, right? Which is minus 10, plus 10. Y is now 0 at 5. And at 6, we've got 36 minus 42, right, which is minus 8, plus 10 is 2. So we're going to stop there. Okay. And if we draw this out now, what we have is a parabola, meaning a smooth curve, which, if we continue, would go like that. The solution to this equation is where it crosses the y-axis, or the x-axis, rather. Pardon?
First time? Or the second time?
Both
It
times.
crosses it
Remember, there are two answers.
yeah,
It's a quadratic equation. So 2 and 5. Okay? Those are the answers. Now, if you factored that, let's look at the factors of this. X squared minus 7x plus 10 equals 0. Okay, we'll go back to factoring and solving for x that way. The factors are x minus 2 and x minus 5. How do I know? Well, they have to be negative times negative because this is negative. Yeah, -2 and -5 make -7. So this becomes x minus 2 equals 0, or x equals 2, and x minus 5 equals 0, or x equals 5. So we can simply plot the quadratic equation and read the answers off the graph. For cubic equations, it does this. So you get 3 places where it crosses the axis. Okay.
That's where it gets fun.
Pardon?
That's where it gets fun.
Yeah, they're a little more fun, a little more challenging. Okay, questions? Now, I will tell you that on the final, when we do that on Wednesday, you'll have graph paper, and you'll be told to solve some quadratic equations. You have now 3 methods of solving quadratic equations: factoring, the formula, and graphing. So if I don't tell you what method to use, choose one of your liking. But remember, some can't be factored. We saw that in the take-home assignment last week. Some cannot be solved by factoring. And that's if you're told to solve by factoring, that is an appropriate answer. Can't do it. If you go ahead and do it by another method, that's okay. Although I guarantee you figuring out what the square root of 2 on one of these things isn't so easy. It's probably better done with the formula that way. But you can see that there are multiple ways that we can solve quadratic equations as well. I picked this one obviously because I knew the answers ahead of time. Because I could factor it. But I wanted to show you how this works. Wherever it crosses the x-axis is the value of x that solves the equation. And with linear equations, pairs of linear equations, you now have at least 3 methods that you can use to solve those, if they have solutions. Clearly, there are examples where you can't solve. A good example would be where the lines are parallel, meaning there's no intersection point. Then there's no solution, no common solution, right, to those. Since they're parallel, the same solution set will apply to both, which is an infinite number. The only restriction being that it has to be related by the slope, right? So now we have several different ways of going about this. Graphical analysis is something you'll get more into when you take statistics. You'll see a little more of that. When we get into statistics, assuming you take it from me, you will talk a lot about the presentation of data and how the many different ways of graphical presentations, all of which you guys have seen, pie charts and bar charts and that sort of thing. You're all familiar with those. There are lots of ways that we can use that information to present a different picture than the data actually tell us. Advertisers are great at presenting the truth in a way that implies something completely different. And politicians are even better. Okay. So, questions? Okay, so in this class we have covered order of operations, we've covered solving simple equations, we've covered factoring, we've covered quadratics, we've covered linear equations and solutions of pairs of linear equations. Now we've talked about the use of graphical presentations and graphical formats to actually come up with solutions. So those are the things that you can expect on the final on Wednesday evening, which we will take after I answer any questions you may have. Okay? And we'll finish it. We should be able to finish that in class. I'm in the process of preparing it now, the final. It will be of a format that will have a lot of questions. But what I will do is set it up to where if you get approximately 80% of the answers correct, you'll get full credit for the exam. Okay? So keep in mind that when you're working on the final, I want you to work through it carefully. Don't rush through it. If you come to a problem you don't know how to solve, go to the next one. Okay? Come back to it later. You may solve the next problem and say, oh, that's how I do the last one, and go back and fix it. But you will get, as I say, about 80% will get you full credit for the final. And I'm also debating about a couple of kind of extra credit assignments on stuff that we haven't directly covered in class. And that's going to be about word problems. Word problems are problems that we present and say, give you a certain amount of verbal and quantitative information. And then you set up an algebraic formula and solve for the answer. Okay. I've got a couple of those that I think are fairly straightforward, but I would like you to think about word problems. Because really in life, we're faced with them all the time. Somebody's going to say, if I do, let's just say you're looking at inventory at Grease Monkey. You know, just say I've got X dollars of inventory, and I can have 20% more of item A than I can of item B. How many of those two can I buy?
Practical.
Very practical kinds of questions. Interest. Your interest is in banking, Bernard.
Right.
There are problems that ask basically if I invest, say, $10,000 at 1.5% for 5 years, how much do I get? So you have to set up the algebraic expression. So there's several of these things that I can put together. And I'm going to try and get that as being a bit of an extra credit kind of thing, because I really want you to think about that. But I don't want to, we don't have the time to really go into that in a short class period. But you will be faced with those kinds of questions. And I have a few of them, or more than a few, actually. Okay. So, questions? All right. Then, pardon? Is that all? Holy smoke. All right, then let's get started on this. Has anyone heard from Enrique? I'm a little concerned when he doesn't, when he misses 2 classes like that. Okay.